Howdy, my name is Sienna Fernandez, and this is my Biology 111 biofuel video project where I will be discussing renewable jet fuel. Renewable jet fuel, also known as sustainable aviation fuel, was developed in the early 2000s out of concerns over aviation's carbon emissions, is a drop-in replacement for traditional jet fuel made of non-petroleum sources like fats, oils, greases, agricultural wastes, and even carbon captured from the air. As for development status, it's still in the early stages of commercial deployment, so it's not yet widely available, but production is increasing rapidly. Today, it makes up of less than 1% of global jet use, and many airlines use it, aggressively expanding adoption. Public communication includes that several airlines have signed multi-million dollar purchasing agreements, investing in startups, and conducting flight tests and research. There's about 5 airports that have regular sustainable aviation fuel supplies. A benefit of this fuel is its compatibility with existing aircrafts and infrastructure. Sustainable aviation fuel can be blended with traditional jet fuel and used in existing aircrafts without the need of any modification. This makes it relatively easy and a cost effective way for airlines to reduce their carbon footprint and practice sustainability. As opposed to conventional jet fuel, it can cut carbon emissions by up to 80%. This is dependent on the industrial process, supplies chains to airport, and sustainable feedstock. However, there are some drawbacks when it comes to sustainable aviation fuel. One of the main concerns is that it is currently more expensive to produce than regular jet fuel, which can make it a less attractive option when looking to cut costs. Another issue is debate over sustainability of the feedstocks. As the fuel is made from renewable resources, some argue that the production of feedstocks can have negative environmental impacts, which raises questions about the true sustainability of sustainable aviation fuel and whether or not it is truly a viable solution for reducing carbon emissions in long term. To explain a very complicated production process simply, sustainable aviation fuel starts with a biomass, so a material like cooking oil, animal fats, algae, or energy crops are resourced from plants and microorganisms that originally capture carbon through photosynthesis. First, the raw materials are collected and cleaned to remove impurities. Next, the biomass is converted into smaller molecules. This can happen in different ways. Step one would be through fermentation, where microorganisms break down plant sugars, releasing some carbon through respiration and turns them into alcohols, or through a process called hydroprocessing, where fats and oils are treated with hydrogen to form hydrocarbons. Lastly, the options could be gasification or Fischer trope synthesis, where a solid biomass is turned into syngas and rebuilt into liquid fuels. These intermediate products are refined to meet jet fuel standards and finally blended, usually up to 50% with conventional jet fuel, so it works safely in existing aircrafts. Renewable jet fuel greatly reduces carbon impact of aviation, cutting life cycle CO2 emissions by up to 80% and even over 100% if carbon sequestration pathways are used. It can be one of the strongest tools for achieving carbon neutral flight. Economically, it is the fastest growing green industry. By 2030, it could see $44 billion in investments, generating up to $100 billion in economic output by creating thousands of jobs and boosting rural economies and driving new innovations. To accelerate adoption even further, policy support would need to strengthen through financial incentives, clear regulations, and long term commitments. Expanding sustainable aviation fuels infrastructure and building public private partnerships would help bring the fuel to market at the scale aviation needs. Continuing research and certification work is essential to enable 100% use in the aircrafts, which would be going beyond today's blending limits. If funding were not a limitation, we could drastically speed up the transition to sustainable aviation fuel. The first step would be to massively scale global sustainable aviation fuel through large, coordinated investments. Governments could provide strong incentives and grants to build new facilities while also shifting economic support away from fossil fuels and towards renewable energy. At the same time, we would need strict sustainability standards to ensure that increased production is environmentally responsible. We could expand through next generation feedstocks and advanced production technologies, helping unlock fuels that are even cleaner and more efficient. Together, this combination of investment policy and innovation would help establish a true cornerstone of sustainable global aviation. These are the citations that I used. Thank you so much for watching.